What is an interrupt-driven system in embedded C? Imagine working on a project where your microcontroller needs to respond instantly to certain events, like a button press or a sensor signal. Instead of constantly checking for these events, what if the system could automatically jump to handle them whenever they happen? That's where interrupt-driven systems come into play. They make embedded systems more efficient and reactive. In simple terms, an interrupt-driven system in embedded C is a way for the microcontroller to react immediately to external or internal signals called interrupts. Instead of the processor constantly checking if something needs attention, it waits for these signals to tell it when to act. When an interrupt occurs, the processor pauses whatever it was doing, saves its current state, and jumps to a special piece of code called an interrupt service routine, or ISR. This routine handles the event quickly, and then the processor resumes its previous task. Think of it like a busy office worker who is working on a report but gets a phone call. Instead of finishing the report first, they answer the call immediately, handle the urgent matter, and then go back to their report. The system works similarly, making sure important events are handled without delay. The processor uses a table called the interrupt vector table to know where each ISR is located. When an event triggers an interrupt, the processor looks up this table to find the right routine to run. This process is very fast, but it's important to keep ISRs short and efficient so the system can return to normal tasks quickly. Interrupts can be generated by hardware devices like sensors, timers, or communication interfaces. For example, a sensor detecting motion might send an interrupt to wake up the system. Software can also generate interrupts through special instructions, which are useful for requesting system services or switching tasks. Interrupts can be triggered in two ways. Level triggered means the interrupt stays active as long as the signal is present. Edge triggered means the interrupt occurs only when the signal changes from low to high or high to low. Edge-triggered interrupts are often preferred because they prevent multiple triggers from a single event. Using interrupt-driven systems in embedded C offers many benefits. It allows the microcontroller to use its time more efficiently, responding immediately to critical events. It also helps save power because the processor can stay in low-power modes until an interrupt wakes it up. This makes embedded systems more responsive and energy efficient. You see these systems everywhere, from handling button presses in a user interface to managing data transfer in communication protocols like UART, SBI, or I to degrees Celsius. Timers can generate periodic interrupts to schedule tasks, and real-time control systems relying on interrupts to react quickly to external changes. In short, an interrupt-driven system in embedded C is a key method for building responsive, efficient, and real-time capable embedded applications. It replaces slow polling methods with hardware-supported event handling, making your microcontroller smarter and more effective in managing tasks.